This lesson is over solving more linear equations. Example 1, solve. For a, we have 5 over 2x minus 1 equals 3 over 2x minus 4. Now notice this is an equation, and we try to simplify the left side, but there's no like terms. We try to simplify the right side, there's no like terms. So what we now want to do is look for our variables. Are they on the same side? Or are they on both sides? Well, in this case, we have x on both the left and the right side, so we need to choose a side to bring all the x's to. I'm going to choose the left side, which means the 3/2 x on the right side needs to move, which means I need to use the addition property of equality. How do I undo a positive 3/2 x? Well, that would be to subtract 3/2 x, as long as what you do to one side, you must do to the other side. Now notice on the left side, 5/2 x minus 3/2 x. Yes, they're like terms because they have x's, but because they're fractions, we need to look at their denominators. Are they the same? And they are, which means we would keep the denominator of 2 and subtract. Well, 5 minus 3 would give you 2 over 2x, and then we still have the minus 1. Now on the right side, the 3/2 x minus 3/2 x cancels, leaving you with not 4, but negative 4. Don't leave your signs behind. Now notice we do have our x's together on the left side, but what do you notice about that fraction? 2 over 2, can that reduce? Yes, that's the same thing as 1x or x. Now since we have gotten our x's together on the same side, now we want to completely isolate and get x by itself. Looking on the left side, we have x minus 1. Since we read that as subtracting 1, to undo that we must do the opposite operation. The opposite of subtracting 1 is to add 1, but we have to do it to both sides of the equation. And when we do that, that leaves us with x equals negative 3. For problem B, we have a fraction, and in the top we have 3 times the quantity, x minus 2, all over 5, equals 3x plus 6. Now this one is slightly different. That fraction on the left side looks a little more involved. Now there is another approach as a way to get rid of fractions, and that is to use the multiplication property of equality by multiplying the left side of the equation and the right side of the equation by the common denominator. So in this case, what is our only denominator? Well, that would be a 5. So what we do is we multiply the left side by 5 as long as you multiply the right side by 5. On the left side, because it was originally dividing by 5 and we're choosing to multiply by 5, those 5's reduce, leaving you with 3x minus 2. On the right side, because we have 3x plus 6 times 5, we do need to distribute the 5. 5 times 3x and 5 times 6, which gives you 15x plus 30. So now the fraction has been eliminated, so now it looks a little bit easier on the eyes. What do you think you can do next? Well, on the left side, notice that is 3 times the quantity, x minus 2. So let's distribute. That gives me 3x and a negative 6. So now that we've got everything laid before us, now we want to gather our like terms. What side do you want the variables on, the left or the right? So what we're going to do is we are going to move the x's to the right side. So let's subtract 3x on the left side and on the right side. And when we do that, that simplifies to give us -6 on the left side. And on the right side, we have 12x plus 30. Now you could have chosen to have the x's on the left side. I simply chose the right side. It will not change your answer. But now that we have the x's together in a single location, we want to completely solve for x. In my case, I have x's on the right side. So only looking on the right side, I want to keep any terms that have x, which means any terms that do not have x need to be moved to the other side using the addition property of equality, which means that plus 30 cannot stay. So the opposite operation of adding 30 would be to subtract 30 from both sides. And after doing so, that simplifies to give me -36 equals 12x. Now that I've got the x's by themselves on the right side, now I only want the x, so I have to investigate what's happening between the 12 and the x. Are they adding, subtracting, multiplying, or dividing? Well, since they're touching, that means multiplication. So to undo that, we need to divide the right side and the left side by 12. And by doing so, we find x actually equals -3. C. 8x plus 5 times the quantity 2 minus x equals 3 times the quantity x minus 6. Again, this is an equation, so we draw the line at the equal sign. So we look first at the left side, and I want to simplify or do gems as much as I can. Notice I can do nothing inside the grouping symbols. I have no exponents, but I do have some multiplication in the form of the distributive property. We need to distribute the 5. So 5 times 2 and 5 times -x, which gives us 10 minus 5x, and we can't leave that 8x behind. Now still looking on the left-hand side, there's no more multiplication division, but now we look to subtraction and addition, and notice we do have like terms. 8x minus 5x can give you 3x, and then we still have that plus 10. So we've simplified the left side, now we turn our attention to the right side. On the right side of the equation, notice we can do nothing inside the grouping symbols, no exponents, but we do have multiplication in the form of the distributive property. So we distribute 3 times x, 3 times -6, which gives us 3x minus 18. Now we need our equation to be a true statement, meaning we can read it from left to right, so go ahead and bring it down to the next line. Now we see our equation, and now we're on a mission to solve for x. Notice x appears on the left side and the right side, so we must get them on the same side of the equation using the addition property of equality. Now it doesn't matter what side you bring the x's to, you just have to make a choice. For this example, I'm going to choose to bring the x's to the left side, which means the 3x on the right side needs to be eliminated. So how do you get rid of a positive 3x? Well, we subtract 3x. As long as what you do to one side, you must do to the other side. Now on the left side, we have 3x minus 3x. Think of that as if I have 3 apples and then I take away 3 apples. How many do I have left? None, which means on the left side, you only have a 10 left. And on the right side, also 3x minus 3x cancels and you're left with a -18. Now, notice the variable disappeared and we're left with 10 equals -18. Is this true or false? Well, because it's false, 10 is not the same thing as -18. What that tells us is this has no solution. Meaning no matter how creative you get with numbers, no number will ever work in this particular example. Problem D, we have negative 3 times the quantity 2x plus 4 equals negative 6 times the quantity x plus 2. Again, we draw the line at the equal sign, and then next we want to look at the left-hand side, which will be to distribute negative 3 to both values. And we find the left side turns into negative 6x minus 12. On the right side, we need to distribute the negative 6 to both values, which gives us negative 6x minus 12. Now again, we need to get x's on the same side, so you choose the side you want it on. And it doesn't matter. I'm going to choose to add 6x on the left side and add 6x on the right side so that I can get my x's on the same side. Now in this case, negative 6x plus 6x cancels, leaving me with negative 12. And on the right side, negative 6x plus 6x cancels, again leaving me with negative 12. Now notice the variable disappeared. So let's go back and look at the statement. Is that true or false? Well, negative 12 is the same as negative 12, so this is true, unlike the previous problem. Since this is a true statement, that means our solution is all real numbers, meaning any number you can dream up will work. That means a fraction would work, a decimal would work, positive, negative, zero, any number you choose will work and create a true statement for this equation. Now we are going to look at solving equations for a specific variable, meaning we're going to be looking at equations that have more than one letter. So our first example will say solve for the specified variable. For A, we have I equals PRT, and it says solve for R. Now in this instance, because we have several variables, it's very easy to get distracted. I would suggest you color or highlight the chosen variable that you are trying to solve for. In this case, that would be the R, and I've highlighted it already. Now, since R is what we're trying to get by itself, we investigate. Notice R is on the right side, and we look what's happening to the R. Because the P is touching the R, and the T is touching the R, that means those values are multiplying R. So we need to undo the operation. Well, what's the opposite operation of multiplication? That would be division. So we must divide the right side by PT as long as we do it to the other side. And we see P divided by P reduces to 1. T divided by T reduces to 1. And so you're left with R all by itself. On the left side, you cannot reduce, so it will remain I all over PT. And that would be your solution. For B, we have H equals 7AS plus 10A, and this time they want us to solve for the letter S. So again, we want to go ahead and draw the line at the equal sign, and because we have multiple variables, I would go ahead and highlight the specified variable, which in this case is the letter S. Now looking at the equation, what side of the equation is the S on? Is it on the left or the right? Well, notice it is on the right side, so only looking at the right side, we want to move any terms that do not have an S attached to it. And notice we have that plus 10A, which means that needs to be moved to the other side of the equation by doing the opposite operation. So the opposite of adding 10A would be to subtract 10A. As long as you do it to one side, you must do it to the other. And so we're left with H minus 10A equals 7AS. So we have gotten the S term by itself, meaning we have 7AS. The right side just has S's. The problem is S is not by itself. The 7 and the A are touching it. Well, when values are touching, that implies multiplication. How do you undo multiplication? You divide. So we divide the right side by 7a as long as we divide the whole entire left side by 7a as well. And so 7a divided by 7a reduces to s. And on the left side, you cannot reduce, so it will remain h minus 10a all over 7a. And that would be your solution. For C, we have n equals f plus d times the quantity n minus 1. And again, it's asking us to solve for d in this example. Draw your line at the equal sign and then highlight your chosen variable. Now, notice what side the variable is on. Is it on the left or the right? Well, it is on the right side. Now, on the right side, we want to keep any terms that have the d attached to it. On the right side, are there any variables that do not have the d attached to it? Yes. Notice that f is not attached to the d, so we need to remove it. The only way to remove it from the right side is by doing the opposite operation, which means we need to subtract f on the right side as long as we subtract it on the left side as well. And so we're left with n minus f equals d times the quantity n minus 1. Now notice we have the d term on the right side, but d is not quite completely by itself. It's touching this quantity wrapped inside the parentheses. Well, if d is touching the parentheses, that implies multiplication. So how do we undo multiplication? We simply divide. So we divide the right side by n minus 1 as long as you divide the whole entire left side by n minus 1 as well. And we know n minus 1 divided by n minus 1, or any number divided by itself, reduces to 1, leaving you d all by itself. And on the left side, you cannot reduce, so it remains n minus f all over n minus 1. And that would be your solution. For D, we have D equals R over T, and this time we need to solve for the letter T. Go ahead and draw your line at the equal sign, and then highlight your specified variable, which is T. Now notice T is in the denominator in this particular problem. And we need to solve for t, which means we need to get t out of the denominator. So what we do is we are going to multiply the right side by t as long as we multiply the left side by t. All because r was being divided by t, we did the opposite operation by multiplying by t. And since we were fair to both sides, we now have td equals r. We no longer have any fractions to worry about, and t is no longer trapped in a fraction. But now our focus goes directly to the t. I want t by itself. So investigate what's happening to the t and the d. Well, they're multiplying. So to undo multiplication, we must divide the left side by d as long as we divide the right side by d. And any number divided by itself will reduce to 1, which leaves t all by itself, and that will equal r over d. That would be your solution.